Hello, sixth graders. Welcome to your video lesson on greatest common factor. Your learning target is I can find the greatest common factor of two or more numbers. Looking at a lot of vocabulary again today. We're looking for the greatest, largest factor that numbers have in common. You can do this. Okay, so let's be focusing in up here, first of all, into our vocabulary. What we see is some review vocabulary. We're looking at the terms factor and multiple today. A factor is meaning a doer. Well, that's kind of silly if we just look at a dictionary meaning. Everyday meaning. I know I talked to some kids about, someone interviews you after a sporting event and says, what are some factors that contributed to your win? That would be something that actively contributes to a decision or result. And then in math, of course, we have that they are factors of 6. And that's something that make up a product. So we talk about numbers that make up another one. For a multiple, which we'll talk more about in our next video lesson, but a multiple is kind of on the other end is what we're going to. A number has infinitely many multiples. That's what the numbers we are going to after we multiply. So here, a Venn diagram is something showing another vocabulary word, that overlapping circles that show how common elements among sets of numbers are related. So this can help us show common factors. So looking here, if we list our primes of 12, our primes of 18, we'll see that they share 2 and 3. So they would share a factor of 6. That'll make more sense as we go on, but think about that vocabulary. No need to kind of scramble and write all this down, but I definitely would have a review of that vocab for factor, and possibly that Venn diagrams just show us things are in common. Okay, so here is just a picture, just a 3 list. I'm just going to list here the different ways that I'm going to show you how to find the greatest common factor, or what we call the GCF, of two numbers. So the first method is to list the factors. Some of you really love that. That's what that seems most natural, and that is good for when we're using smaller products. Okay, so when we have smaller numbers, that's going to be not so bad because the factors are going to be fewer and just easy to see. Method 2 is using prime factorization. Here it's using a factor tree. You could also use division by primes and then using the prime numbers to be able to tell what the common factor is. Here you can see on this previous method, you can see that we just circle the ones that are in common until we find the greatest one. In this method, you list all your primes, and then you find the primes you have in common and multiply them back together. And then the final one, the cake method, this one's a super simple method. You can see how simple it looks like there's a lot less going on. But in this case, you divide each number by the product that by its factor that they share. So in this case, 16 and 20 share 2, 8 and 10 share 2, 4 and 5, they don't share anything other than 1. So at that point I stop, and again, multiplying those together. So we can see that the greatest common factor, the biggest number that both can be divided by, or that is used to multiply to get to them, is 4. So again, maybe having just an image of those written down, or reference back to that so that you can try them on the next slides. Okay, so I'm going to first show you the 3 methods for finding the greatest common factor of the numbers 18 and 48. My suggestion to you is maybe you watch one, then pause and record it. Do not chase me to write these down. So starting with listing, I'm going to write out the numbers I'm starting with, 18 and 48, and I'm simply going to list the factors. I know that 1 times 18, 2 times 9, 3 times 6. Factors of 48, I know are 1 and 48. It's even, so 2 and 24, 3 and 16. I almost forgot that one earlier. 4 and 12, I'm kind of running out of space. And 6 and 8. Hopefully yours is a lot neater than that. And I can see they share 1, they share 2, they share 3, and they share 6, which appears to be the greatest. Hopefully yours looks nicer than that. Okay, so the prime factorization method, again, you could do a factor tree. or you could do that division by primes. I think we need more practice on the division tree, so I'm going to show that. 18, 48, do my factor tree for both. So 18, I might start with 2 and 9. If you start with 3 and 6, that's totally fine. And we're listing those out. So notice it says step 1 is to factor the tree. So I'm going to do that first. 2 and 24, 2 and 12, 2 and 6, 2 and 3. Step 2 is to find the shared prime factors. So first I'm going to write them out. Guess that should be the next thing. 2 times 3 times 3 compared to, and I line them up top to bottom. Line them up. 2 times 2 times 2 times 2 times 3. And so then I'm going to find those shared prime factors. They share one single 2 and they share one single 3. If the other one had another 2 and another 3, then they'd share those. Step then 3 is to multiply. 2 times 3, greatest common factor of 6. Notice it should be the same as what we got previously with the other method. So the last method here is the cake method. So it's called the cake method because it kind of stacks and looks like a cake. So you're starting with 18 and 48. It's kind of like an upside down division, kind of like division by primes. Pick a number that we know they both share, a factor they share, because we're looking for common factor, which I know is 2 in this case. So then I divide and I get 9 and 24. So I think of a common factor that 9 and 24 share, and I know that that's 3. So then I get 3 and 8. 3 and 8 do not share any factors other than 1. So I'm done here. Notice 2 times 3, they shared a factor of 6. So the greatest common factor of 18 and 48 is 6. Okay, now I would love it if you tried. Try to find the greatest common factor of each of these pairs of numbers. You can use any of the methods you'd like. I'm noticing that these are all pretty small numbers, so I'm thinking listing might be helpful for some of them. But I'm going to show you other ways. So go ahead and try if you'd like, and then come back to check. So for 8 and 10, I'm just going to list 8 and 10, my factors. 1 times 8, 2 times 4. Factors of 10, 1 times 10, 2 times 5. Those are my factors, so I can see that they share a factor of 1, and they share a factor of 2. So my greatest common factor of 8 and 10 is 2. For 6 and 12, I'm going to decide to do a factor tree. And I see that 6 has factors of 2 and 3. 12 has factors of 2 and 6. 2 and 3 from the 6. I write those out, 2 times 3, as well as 2 times 2 times 3. I circle the ones I have in common, the 2 and the 3, and I multiply. 2 times 3 is 6. So the greatest common factor of 6 and 12 is 6. So sometimes the number itself will be the factor if it's a factor of another number. Last one, we have 10 and 17. I'll try the cake method here. 10 and 17. What I notice is that 17 is prime. Therefore, I know that its only factors are 1 in itself. So this means that they can only share a factor of 1. 1 goes into both 10 and 17. So 1 is the greatest common factor. Sometimes that's the case, and that's especially the case when one of the numbers is prime. So if you try different methods, that's great. I hope you got the same thing doing it a different way. Because math is not about everyone doing everything exact. It's about doing things that make sense to us with numbers. So when trying to find the greatest common factor of 3 numbers, any of the 3 methods you've previously tried can work here. So go ahead and try any method you'd like, the one you feel more comfortable with, and then you can come back and check. So what I might try is, I'll try 2 methods just to show you. So 12, 34, and 60. I'll try the cake method to start. So what I notice is that they're all even. So what I might start with is dividing by 2, a common factor. And I get 6, 17, and 30. Noticing again that I have that prime number of 17. Knowing that, if 17 isn't a factor of the other ones, then the only factor they share is 1, therefore leaving me with a greatest common factor. That's a C. Greatest common factor of 2. The same would be true if you wanted to list your factors. The same would be true if you wanted to do a tree method and list your primes. If you did one differently, that's great. I'll just leave that one here. Now is a great place for you to try. Don't be afraid of messing up. Just give it your best shot. Either try one that you're thinking that you might be most comfortable with, or try two methods here just to see if you match up and get the same answer. So when you're ready, come on back. I'm going to do on this one, I'm going to start with the prime factorization. So I'm going to make a factor tree for each of these. 3 and 10 are factors. And then I'm going to list them below and I'm going to stack them up. So 2 times 3 times 5 were my factors for 30. For 45, I'm going to prime factorizate this one. So again, I'm factoring until I end up with only primes left. Then I'll write those. Again, you can check them to make sure you did it right by multiplying those back and seeing if they make that product. Factoring these all the way until I only have primes. And then stacking them and looking at what they have in common. So when I look at what they have in common, I see that they all have a 3 and they all have a 5. So 3 times 5 is 15. So the greatest common factor of 30, 45, and 75 is 15. So for good measure, I'm going to do the cake method just to see that I can solidify that I'm accurate. Try it a couple different ways. So because these are ending in 0s and 5s, I know that they share a factor of 5. So I'll start with that. 5 times 6 is 30. 5 times 9 is 45. 5 times 15 is 75. And I know that because 5 times 4 is 60. And 15 times 4 is 60, and that's an additional one. Now I see here that these share a factor of 3. 3 goes into 6 twice. 3 goes into 9 3 times. 3 goes into 15 5 times. Now I see that these are all prime numbers, so they're only going to share 1. So I can stop there. And the common factors I was able to divide by, 5 times 3, which again, greatest common factor of 15. Word problem, real world example. All right, so no fear, let's work through this. You might have to read it more than once, and that's okay. The Irish cheerleaders are making spirit ribbons for upcoming Spirit Week. Blue ribbon comes in 24-inch spool. Green ribbon comes in 30-inch spool. And gold ribbon comes in 36-inch spool. The cheerleaders want to cut strips of equal length and use the entire spool of ribbon. What is the length of the longest ribbon that can be cut from each spool? Here's what I know. I know that when we're wanting to cut them in equal parts, that's them telling us that we want no remainders. We don't want any leftover ribbon. So what we need is we need to find a factor that all are divisible by. That's what we want to know. So what we're looking for is the greatest common factor of 24, 30, and 36. These numbers are fairly small, so I'm just going to do my listing method. You are welcome to do another one. And hey, if you want to pause here and try on your own, great. So I get 1 times 24, 2 times 12, 3 times 8, and 4 times 6. For 30, I know 1 times 30, 2 times 15, 3 times 10, I might have got too small here, 5 times 6. For 36, 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. So I look for those common factors. They obviously all share 1. They share 2. They seem to share 3. Not 4. They share 6. And that looks like it. So that looks like our greatest common factor here is 6. So what that means is that is the length of the longest piece of ribbon that can be cut from each spool. So to name that correctly, we would say, based on the question, what's the length of the longest piece, we would say that is 6-inch pieces. I'm suddenly using the highlighter. So the question below then, how many spirit ribbons can be made if the ribbons are cut into 6-inch pieces? Well, that means that with a 24, we are going to divide that by 6-inch pieces. How many 6-inch pieces fit in there? And that's 4 of the blue. For the green, it was 30 inches. How many times does 6 fit in there? That's 5 6-inch green ribbons. And then for the 36-inch gold, that's 6 6-inch gold ribbons. All right, team, you can do this. This is your time to shine. You can do it. Do this in your notebook or in your notes template, wherever you're working. Find the greatest common factor of each of these questions. That's it. That's all. Show your thinking, though. Don't just write the answer. Show me what method you're using. Maybe you'll use each method once. Maybe you'll try the same method each time. Do your best. Show your thinking. I can't wait to see it. Look back over your notes. Try to explain this to a friend. Review anything that you need to, and make sure you bring your questions and learnings to class.